What if I told you that the edge of our solar system isn't a quiet, empty void, but a colossal, invisible wall, a spherical cage forged in violence, made of trillions of mountain-sized ice chunks that encircles our sun and every single planet within it? This is the Oort Cloud, a ghostly frontier that marks the last gasp of the sun's influence before the true, crushing emptiness of interstellar space begins. We've never seen it, not with Hubble, not with Webb, not with our most powerful instruments. Yet the evidence is overwhelming that it's not only real, but it could be responsible for unleashing cosmic devastation upon Earth, acting as a celestial sniper with a patience of millions of years. It is arguably the single largest and most massive structure in our solar system, and yet it remains a complete ghost. How do we know this invisible realm exists? What terrifying secrets is it hiding in the dark? And could it be the source of our planet's next great extinction? You've likely heard of the asteroid belt, that chaotic junkyard of rock and metal tumbling through space between Mars and Jupiter. It's the remnant of a planet that never formed, a region of cosmic rubble. You might even know about the Kuiper belt, the icy donut of debris that lies beyond the orbit of Neptune, home to dwarf planets like Pluto and Eris. Both of these structures are relatively orderly. They are like flat, spinning records, with most of their material moving in the same direction and on the same plane as the planets. They are the known, mapped, and somewhat predictable suburbs of our solar system. But the Oort Cloud is something else entirely. It's not a belt or a ring. It's a massive, thick-shelled sphere that surrounds everything. Imagine our solar system. The sun, the planets, the belts, is a tiny ship in a bottle. The Oort Cloud is the bottle itself, a vast, spherical container enclosing it all. It's a ghost in our own backyard, a structure so incomprehensibly vast that it dictates the true boundary of the sun's gravitational kingdom. Its contents don't play by the normal rules. They aren't in neat, flat orbits. Instead, they hang in the darkness like a static swarm, a cosmic beehive of dormant comets, moving in every conceivable direction. They float in a state of near-perfect preservation, a chaotic sphere marking the dark frontier between our home and the great cold unknown. This isn't just a boundary, it's a loaded weapon, aimed inward. But if this colossal sphere is completely, utterly invisible, how did we ever find out it was there? The credit goes to a brilliant Dutch astronomer named Jan Oort, who in 1950 became a true cosmic detective. He wasn't looking for a giant sphere of comets. He was trying to solve a different puzzle that had vexed astronomers for decades, the mystery of long-period comets. Unlike Halley's Comet, which predictably returns every 76 years from the Kuiper belt, these other comets were wildcards. They appeared seemingly from nowhere, on orbits that took thousands or even millions of years to complete. More strangely, they came at our solar system from all angles, plunging down from above, rising up from below, and hurtling in from the sides, completely ignoring the flat plane of the solar system. Working with photographic plates and painstaking calculations in a pre-computer era, Oort noticed a few crucial clues. These comets were moving on incredibly elongated, almost parabolic orbits, which meant they were falling from an immense distance and would be flung back out to that same distance. He traced their paths backward, calculating their aphelion, the farthest point in their orbit from the sun, and he found a stunning pattern. They all seemed to originate from a similar mind-boggling distance, tens of thousands of times farther from the sun than the Earth. They had to be coming from a single vast reservoir. Oort theorized that there must be a gigantic spherical shell of these icy bodies out there, a remnant from the solar system's birth. Most of the time, these objects orbit in perfect, cold silence, but occasionally, a tiny gravitational nudge, perhaps from a passing star, a giant molecular cloud, or the tidal forces of the Milky Way galaxy itself, could disturb one of these dormant comets. This tiny push is all it takes to send it on a new path, a slow million-year fall toward the sun. Jan Oort, much like a detective finding a single footprint that proves the existence of an unseen predator, saw the clues without ever seeing the source. He gave us the first glimpse of the solar system's hidden architecture. The origin story of the Oort Cloud isn't a peaceful tale of cosmic leftovers. It is a story of unimaginable violence, a testament to the brutal and chaotic infancy of our solar system. It is a graveyard of shattered worlds and planetary fragments, 4.5 billion years ago, our planetary neighborhood was a lawless demolition derby. The giant planets, especially Jupiter and Saturn, were gravitational bullies, migrating wildly through the solar system in a process scientists now call the NICE model. In this model, the giant planets formed closer to the Sun before shifting dramatically to their current positions. Jupiter, in particular, was a wrecking ball. Its immense gravity, more than 300 times that of Earth's, acted like a colossal slingshot. As it moved, it grabbed hold of trillions of smaller icy bodies, known as planetesimals, and flung them with terrifying force. These planetesimals were the building blocks of planets, rich in the very materials that would later form life: water, methane, ammonia, and complex organic molecules. Many of these objects were ejected from the solar system entirely, banished to become lonely wanderers in interstellar space. But a significant portion weren't thrown quite hard enough to escape the Sun's gravitational leash. They were launched into bizarre, extremely elongated and tilted orbits, creating a chaotic, diffuse sphere of debris that slowly settled over billions of years. The Oort Cloud isn't just a collection of debris, it's a cryogenic arc, a frozen record of the exact chemical composition of the primordial cloud that formed our Sun and planets. These aren't just ice balls, they are time capsules, each one holding the pristine 4.6 billion-year-old ingredients of our solar system. The cloud's total mass is uncertain, but some estimates suggest it could be 5 to 10 times the mass of the Earth, all scattered across a volume of space trillions of times larger than the space occupied by the planets. It is the solar system's birth scar, a permanent reminder of its violent creation. To say the Oort Cloud is far away is a staggering understatement. Its scale is almost impossible for the human mind to process. So let's try a few analogies. If the Sun were the size of a marble placed on the goal line of a football field, Earth would be a single grain of sand about 3 feet away. Jupiter would be 16 feet away. Neptune, the farthest planet, would be just past the 10-yard line. The Kuiper belt would extend to about the 15-yard line. But the Oort Cloud wouldn't even begin until it was 20 miles down the road, and it would extend for over 300 miles in every direction, forming a sphere with a diameter wider than the state of Florida. It is a realm of absolute, profound emptiness. While there may be trillions of objects within it, the space between them is so immense that each comet is on average tens of millions of miles from its nearest neighbor. If you were standing on one, you would be in total darkness, unable to see any others. Our fastest and most distant spacecraft, Voyager 1, has been traveling for over 4 decades at more than 38,000 miles per hour. After leaving Earth in 1977, it has crossed the orbits of all the planets and has officially entered interstellar space. Yet it would still take that ship another 300 years just to reach the inner edge of the Oort Cloud. To fly all the way through it would take an astonishing 30,000 years. This structure is so vast, it blurs the line between our solar system and the rest of the galaxy. Its outer edge reaches over a quarter of the way to the next nearest star, Proxima Centauri. It's not just in our solar system, in many ways it is the solar system. For billions of years, this cloud of icy assassins has floated in near total silence, a realm of perfect cold, just a few degrees above absolute zero. But it's not always undisturbed. About 70,000 years ago, when early modern humans were beginning their migration out of Africa, our solar system had a dangerously close call. A dim star system known as Schultz's star, a binary pair consisting of a faint red dwarf and an even fainter brown dwarf, didn't just pass by our neighborhood. It plowed directly through the outer regions of the Oort Cloud. Astronomers discovered this cosmic intrusion by meticulously tracking the star's motion and velocity, then rewinding its trajectory through space. Their calculations showed that 70,000 years ago, it came within 52,000 astronomical units of our Sun. Deep inside the Oort Cloud's territory, this wasn't a friendly visit, it was a stellar intrusion. The star's gravity, though weak compared to the Sun's, would have sent ripples through that region, gently but inexorably nudging some of the icy bodies from their stable, ancient orbits. While it didn't trigger an immediate, catastrophic comet shower, it serves as a chilling reminder of our vulnerability. The effects of such a passage aren't instantaneous. A comet nudged by Schultz's star could take up to 2 million years to complete its slow fall toward the inner solar system. We may, at this very moment, be living in the shadow of that event. with comets sent our way by that star still on their long journey. We were lucky that time Schultz's star is small and was moving quickly, but the galaxy is a busy place, and a larger, slower moving star could one day unleash a storm of biblical proportions. But what if the greatest danger wasn't from a random passing star? What if our own sun held a darker, more sinister secret? This leads us to one of the most controversial and terrifying theories in all of astronomy, the Nemesis theory. This idea, first proposed in the 1980s by physicist Richard A. Muller, suggests that our sun is not alone. It might have a hidden companion, a small, incredibly dim star, perhaps a red dwarf, or an even colder brown dwarf, locked in an enormous, elongated orbit that takes it far out into the Oort Cloud. Every 26 million years or so, this evil twin, fittingly dubbed Nemesis, would swing through the densest part of the cloud on its orbit. Its gravitational passage would be catastrophic. It would be like kicking a beehive the size of a solar system, dislodging a billion comets and sending a deadly sustained shower of impacts into the inner solar system for up to 1 million years. Proponents of this theory point to the Earth's fossil record, which seems to show that mass extinctions happen with a chillingly cyclical regularity, roughly every 26 to 30 million years. The impact that wiped out the dinosaurs 66 million years ago wouldn't be a random event, but just one deadly bullet in a prolonged fusillade, fired by our sun's hidden companion. So why haven't we found it? A brown dwarf, a failed star, would be incredibly dim and cool, emitting almost no visible light. If it's currently at the farthest point of its orbit, it would be nearly impossible to spot with our current telescopes. However, major infrared sky surveys, like NASA's WISE telescope, have scanned the entire sky for such objects and have found no evidence for Nemesis. While this has dealt a major blow to the theory, it hasn't killed it entirely. The hunt for a ghost star that might be responsible for Earth's greatest catastrophes continues, a search for a trigger to a cosmic gun that may already be aimed at us. As if our own solar system's hidden dangers weren't enough, we are now discovering that the universe is full of cosmic wanderers, objects that have been ejected from their own star systems. In 2017, astronomers detected the first known interstellar object, a bizarre cigar-shaped body named Oumuamua. It tumbled through our solar system on a hyperbolic trajectory, meaning it was moving too fast to be captured by our sun's gravity. It was just visiting. Its strange shape and the fact that it accelerated away from the sun without any visible comet tail led some to speculate it could be an alien artifact. A more plausible, though still exotic theory, is that it was a nitrogen iceberg, a fragment of a Pluto-like planet from another star system. Just 2 years later, a second interstellar visitor, 2I Borisov, was discovered. This one, however, looked and behaved exactly like the comets from our own Oort Cloud, spewing gas and dust as it neared the sun. The discovery of Borisov was profound. It suggested that Oort clouds are not unique to our sun, but are likely a common feature around most stars. This means that every star in the galaxy is likely surrounded by its own swarm of trillions of comets. The galaxy is filled with these ghostly halos. This raises a mind-bending possibility. Oort clouds from different stars might even overlap and trade comets. The comet that you see in the night sky might not be from our solar system at all, but an exile from a star system hundreds of light years away, a journey that began before humans ever walked the Earth. So, we are left with a profound and unsettling paradox. The Oort cloud is likely the largest and most populous structure in our solar system, a sphere that stretches nearly a quarter of the way to the next star. It is the solar system's attic, holding the pristine materials of our creation. It is the birthplace of comets that have inspired wonder and art for millennia. But it is also a potential executioner, a source of impacts that have punctuated Earth's history with devastating mass extinctions. Yet, we are completely blind to it. The trillions of chunks of ice and rock that form it are as dark as charcoal, and are so far from the sun that they reflect virtually no light. They are too small, too dark, and too far away to ever be seen directly. We only know it exists because of the ghostly messengers it sends us, the long-period comets that streak across our skies, reminders of the immense and volatile power lurking in the darkness. The Oort cloud remains a ghostly enigma, a dark and silent reminder that the most massive and influential structures in our universe can hide in plain sight. holding the secrets of both our origin and perhaps one day our destruction.